In the waning days of December 2021, residents of Texarkana, Texas, stepped out of their homes after a severe thunderstorm to confront a scene that defied all conventional logic. The pavement, lawns, and rooftops of their suburban neighborhood were scattered with hundreds of small white bass lying motionless miles away from the nearest lake or river. There had been no localized flooding to wash them ashore, nor any human intervention to explain their sudden, bizarre appearance. The clouds had simply opened up, dropping aquatic life alongside the heavy precipitation, leaving a bewildered community staring up at the sky. This modern anomaly is far from an isolated incident, echoing through centuries of human documentation. Historical records indicate that the Roman naturalist Pliny the Elder documented storms of frogs and fishes in the 1st century, treating them as ominous marvels of the natural world. Throughout the Middle Ages, similar events were frequently interpreted as divine retribution or apocalyptic portents, etched into manuscripts by monks who struggled to comprehend how the contents of a pond could materialize from the heavens. For millennia, humanity has looked to the sky in bewilderment as it delivered creatures of the earth and water, sparking myths that have endured into the modern era. We are forced to ask how aquatic life bypasses the relentless pull of gravity to become airborne precipitation. The sheer physical force required to extract a living creature from its natural habitat, elevate it thousands of feet into the air, and suspend it within the turbulent troposphere completely defies our everyday intuition. It is a seemingly impossible event that challenges our fundamental understanding of weather, demanding a rigorous, grounded meteorological explanation rather than a reliance on folklore or superstition. Meteorologists point to a specific, violently rotating column of air as the primary culprit behind this phenomenon, the tornadic waterspout. When a severe thunderstorm moves over a body of water, it can spawn a vortex that connects the storm cloud to the water's surface. Unlike weaker, fair-weather waterspouts, these tornadic systems act as massive, localized vacuums, drawing surface water, debris, and unfortunate aquatic inhabitants upward into the swirling, low-pressure core of the funnel. The mechanics of this atmospheric power are staggering to consider. Updrafts within severe supercell thunderstorms can easily exceed speeds of 100 miles per hour. These vertical winds are so immensely powerful that they completely overpower the terminal velocity of small aquatic animals, lifting them high into the dark, churning interior of the storm clouds. The creatures are not merely sucked up, they are violently propelled into the upper reaches of the atmosphere. Atmospheric scientists hypothesize that once these animals are trapped within the turbulent interior of a cumulonimbus cloud, they can be carried for dozens of miles inland. The storm essentially becomes a chaotic, high-altitude transit system. As the creatures are swept upward, they often encounter freezing temperatures, which explains why eyewitnesses frequently report finding fish or frogs encased in solid blocks of ice upon impact. They remain suspended in this brutal environment until the storm weakens, the updraft dissipates, and gravity finally reclaims its hold. Yet a perplexing detail emerges when we examine the fallout of these bizarre weather events. Eyewitnesses and investigators consistently report that it rains only one type of animal at a time during these showers. A sudden deluge of frogs is virtually never mixed with a shower of fish, nor is it accompanied by a scattering of aquatic plants or mud from the same pond. This bizarre uniformity suggests an aerodynamic sorting process at play within the chaotic heart of the storm. Researchers propose that objects of similar mass, aerodynamic shape, and density are deposited together as the wind speeds within the cloud begin to fluctuate. Just as a centrifuge separates materials by density, the varying currents of the storm effectively categorize the animals mid-air, dropping the heavier creatures first while carrying the lighter ones further downwind, resulting in a strangely uniform biological precipitation. To truly understand the depth of this phenomenon, we must look to the municipality of Lloro in Honduras, where the anomaly is deeply woven into the local fabric. Here, the lluvia de peces, or rain of fish, is not considered a once-in-a-lifetime freak occurrence, but rather a predictable event that locals claim happens almost annually. Following intense spring storms, Residents routinely gather silver, sardine-like fish from their saturated pastures, transforming a meteorological mystery into a celebrated cultural staple. For over a century, the sheer predictability of the Euro events has challenged the random, chaotic nature of waterspout theories. If a waterspout is a localized, unpredictable weather event, it seems highly improbable that it would strike the exact same region, depositing the exact same type of fish year after year. This geographical consistency forced investigators to look beyond the sky and examine the ground beneath their feet. In the 1970s, a team of researchers from National Geographic arrived in Honduras to document the aftermath of the legendary rain. They found the fish scattered across the fields just as the locals had promised, but their biological analysis revealed a staggering twist. The specimens collected from the grass were completely blind, lacking functional eyes entirely, a trait highly characteristic of subterranean, cave-dwelling species rather than surface water fish. This crucial discovery birthed a compelling competing scientific theory. Experts suggest that these specific fish in Euro are not raining from the sky at all. Instead, they hypothesize that the intense torrential rains cause local underground water tables to rise rapidly, forcing these subterranean fish out of their hidden limestone caves and onto the surface. In this specific instance, the grounded explanation shifts dramatically from the raw atmospheric power of a waterspout to the intricate, hidden geological plumbing of the region. Whether pulled violently from the sky by a vortex or pushed up from the earth by rising waters, investigating these events reveals the profound, often hidden ways weather interacts with local ecosystems. The boundary between the atmosphere and the biosphere is far more porous and dynamic than we typically imagine. The environment is not a set of isolated systems, but a deeply interconnected web where atmospheric pressure, geological formations, and biological life constantly collide. Despite our technological advancements, capturing the exact, definitive moment of levitation remains incredibly elusive. We are almost always forced to rely on the aftermath, piecing together the scattered evidence left on the pavement or in the fields. Pointing high-definition cameras into the dark, chaotic, and destructive heart of a tornadic waterspout is both technically difficult and exceptionally dangerous, leaving the actual mechanism of extraction shrouded in the mist. Modern meteorological tools, however, are slowly beginning to close this investigative gap. Advanced dual polarization radar systems can now differentiate between standard meteorological precipitation, like rain or hail, and biological debris suspended in the air. This technology allows forecasters to track flocks of birds, swarms of bats, or massive clouds of insects caught in weather systems, providing a new lens through which to observe the sky's hidden cargo. Applying this cutting-edge radar technology to severe coastal storms may soon allow scientists to map the exact trajectory of raining animals, tracking a school of fish from the moment they are lifted from the ocean to the moment they are deposited on a suburban lawn. But until that definitive, undeniable data is captured and analyzed, the human experience of these events remains one of profound, visceral disorientation. Finding a living, breathing aquatic creature miles from the nearest drop of standing water shatters our fundamental expectations of the natural order. It is a jarring reminder of our own vulnerability in the face of nature's unpredictable forces. The science behind raining animals transforms a seemingly impossible phenomenon into a powerful testament to the Earth's raw, unbridled energy, proving that our atmosphere is not just an empty void, but a dynamic ocean of air capable of moving life across the sky.